All right. So, welcome. We're going to be looking at balancing chemical reactions today. So, um, we'll start by, just talking about the law of conservation of mass. So, we're balancing chemical reactions. We want to make sure that what we have on the product side is the same as what we have on the reactant side. So, for balancing chemical equations, so first thing we want to do is talk about the numbers. When you download this, it'll be a little bit easier. So these numbers in the front of each term or each chemical or compound, these are called coefficients. And then the numbers at the bottom, these green numbers, these are called subscripts. So we use coefficients for balancing. We never use subscripts for balancing. That's something that's really important that you need to know. Never use subscripts for balancing. Only coefficients are used to balance equations. We'll use the subscripts when we write the chemical formulas. All right, so then on this side we have reactants, on this side we have products, and then you'll be able to see it a little bit better once you're downloading this. And we're going to practice that. So on this one, yeah, we can see that there's one nitrate group, there's two here, and everything else is balanced, but we're going to practice balance it through the balance. All right, so we want to make sure that law of conservation of matter is observed. We can't have it created or destroyed. We have the same number and types of atoms on the products and the reactant side. So we'll start with step number one and go down. And again, we're not doing rocket science, so it's wait. Yeah, we are doing rocket science. So we are doing rocket science, but we're going to do it in an easy way. So we're following the steps. Like these steps, they're not very intricate. There's not a high level of intelligence required to follow the steps, but there is a high level of effort required. So this is more about the effort that you're going to make. Just get the pen, get the pencil, get the writing. All right. So number one, draw a line between the reactants and the products. So the reason I made the step like this is because everybody can get started with step number one. There's nobody that says, hey, you know what, Mr. Cantor, I don't know how to draw a line. So let's start with step number one. All right, so here are my products over here. Here are my reactants over here. Step number one says that we just need to draw a line between them. So we're going to draw our line here. No problem. Mr. Cantor, I don't know how to do this. Oh, you know how to draw a line. So we're going to make a little effort, draw the line. Let's go. Okay, step number two, list all elements in the reaction. Hydrogen should be listed last, and oxygen should be listed second to last. Except in a combustion reaction, then we'll flip those. So I'm going to list all the elements that I see. I'll just use the reactant side to list them, and then hydrogen should always be listed last. This is going to help with balancing. If you do the balancing correct, the oxygen and hydrogen will automatically balance. So hydrogen is last, oxygen is second to last. And then if we're doing a combustion, we'll switch it up from OH to HO. All right, so step number two. Here we have Na. This side we have Na. Over here, anytime I see something in parentheses or polyatomic ion, I'm going to write that as if it's one term because it's on the left side and on the right side. So I have a sulfate here, Okay, no problem. Then I have an iron on this side, and then an iron on this side. And then now I'll look for any other oxygens. Okay, oxygen. This oxygen is inside of a sulfate group, so I'm not going to count it. And then I'll look for hydrogen. There's no hydrogen present, so and it's not a combustion reaction. All right, so now we'll take a look. What's the next step? We'll follow the step. Step number three, use coefficients to balance both sides of the equation. That's pretty easy. So what we're going to do is over here, we'll start looking. So over here, this sodium, we have 2. So there's 2 over here. And then on this side, for sodium, we only have 1. So these are balanced. To balance these out, we need the LCM of 2 and 1. So factors of 2 are 2, 4, 6, 8, 10. Factors of 1 are going to be 1, 2, 3, 4, 5, 6. All right, so for the least common multiple, we have multiples that are common: 2, 4, 6. These are all common multiples of 2 and 1, but the least common multiple is going to be 2. So I know that on both sides we want to have 2 to make sure it's balanced. So over here, we already have a 2, so that's fine. Over here we have a 1, and then what factor do I need to multiply it by? We're going to multiply that by a factor of 2. So this 2, now that it's here, and I need to multiply, it goes on the underscore. So my coefficient goes on the underscore. I draw these underscores in front of each compound or element every single time. That way I don't make a mistake about where I need to be putting my multipliers in. So I underline my factor, and then I put it on one of the underlines in the equation. Over here, we have one sulfate group. Over here, we have one sulfate. Over here, and these are already balanced, so no work is needed. Over here, we have one iron. Over here, we have one iron. These are already balanced, so no more extra work is needed. Now, for the last step, you got to make sure you go back through and make sure nothing became unbalanced. So when we're balancing, things become unbalanced, and if we don't check, we can get into a situation where at the end, we've gone through and balanced everything, and the equation is still unbalanced. So let's take a look at that. Here we have 2 sodiums, 2 sodiums. Here we have a sulfate group. Here we have a sulfate group. Here's an iron. Here's an iron. Okay, so this one is fine. Lastly, what I like to do a lot of times is I'll put in 1s to fill in the spots. Okay, so, that was a pretty easy one. All right, so now what we'll do is, this one is a little bit more difficult. So now we have some H's and some O's in there. And first step is draw a line. Mr. Cantor, oh my God, I don't understand. We know how to draw a line. Get it drawn. Let's go. All right, so we'll do CA, CA. And then hydrogen is going to come last. Oxygen is always second to last. So I kind of skip over these first. And we have nitrogen, nitrogen. Okay, so that's everything. All right, so now oxygen is second to last. So we have oxygen present. And then H's are going to be last. And then what we should see is that a lot of times oxygen and hydrogens will automatically balance. So that's why I do oxygen second to last, and then hydrogen is last. All right, calcium on this side is a 1. Calcium over on this side is a 3. Least common multiple of 3 and 1 is 3, so I'm going to multiply by a factor of 3. I underline to indicate that it's going in the underlined part, 3. All right, and then here nitrogen is 1. Nitrogen on this side is 2. Least common multiple of 2 and 1 is going to be 2. So I'm going to underline 2, make sure it goes here. And then now for oxygens over here are 3. Oxygens over here are 1. 3 and 1 is 3, multiplied by a factor of 3. And then now we have over here 6 hydrogens. 2 times 3 is 6. 3 times 2 here is 6. So we can see that these automatically balance. I always go back through and make sure, but I know that the hydrogens are balanced, so everything now should be already balanced. 3 calciums, 3 calciums, 3 oxygens, 3 oxygens, 6, 6, 2 nitrogens, 2 nitrogens, and then I might go through and put in my 1s as placeholders, although you don't need to. It is something that's pretty. Lastly, we're going to take a look at a combustion reaction. All right, nothing's changed. Combustion reactions take a little bit of thought process. Little bit. Don't turn it up to 10. I know you guys are smart, but listen. This is not a doctoral thesis. This isn't Georgia Tech. We're just going to use a little bit of brain power, all right? And turn it up to 10. We'll be way in left field. Easy, easy. All right, let's go. All right, so anytime when I'm doing combustion reactions, first thing I'm going to be looking at is I want to look and see if the hydrocarbon is an odd hydrocarbon or if it's an even hydrocarbon. So this one is an odd hydrocarbon, easy peasy, no problem. This will be pretty easy. If I see an even hydrocarbon, we're gonna have to use a little extra brain power. Not on 10, not on 10. Maybe like 6.5, 7. That's enough. That's enough. Bringing a bazooka to a mosquito. All right. First step is the same. We draw a line. Now we're gonna list our elements. Carbon. On this side, carbon is on this side. And then H's are always last, except for combustion reactions. So anytime I have a combustion reaction, I'll just write the acronym CHO, CHO. And that'll take care of carbon, hydrogen, and oxygen. Oxygens we can sometimes get to balance automatically. All right. So over here we have 3 carbons. Over on this side we have 1 least common multiple of 3, and 1 is 3. So we have a multiplier of 3. Then let's see, over here we have 8 hydrogens. Over here we have 2. Least common multiple of 2 and 8 is 8. So we need to multiply by a factor of 4. And then now we can look at the oxygens. Oxygens don't necessarily automatically balance in combustion reactions, but when we list the last, it makes it a lot easier. All right, so over here we have 2. Over here we have 4. Least common multiple, 4. I need a factor of 2. And then I need to go back through, make sure nothing became unbalanced. If you did it correctly, you shouldn't have any problem. C3, 3, 8, 8, 4, 4. No problems, automatic. So now next, let's look at one that has an even carbon. That's going to take us into deep water. This will be the most challenging one. If you can do the even carbon, hydrocarbon combustion reactions, it's going to be great. All right, so now we have a combustion reaction, and this time we have an even carbon. So even carbon means we got to use some brain power on this one. This one's going to take some effort. So I just kind of hunker down, slow down, take my time. It's not a race. You don't get extra points. If you do it real fast and get the wrong answer, there's no extra credit. Dr. Bachman's not coming upstairs. Oh man, they almost got a good grade, but you got it. So take our time, get the right answer. I can only take off points if you make mistakes. So no mistakes. Take our time. We have time. This is easy peasy. Not a high level of difficulty, but it is a little bit. It's intricate. We'll see. All right. So step number 1, we're going to draw a line between our products and reactants. We haven't launched a rocket to Mars or anything. We haven't come up with a cure for the common cold. We just drew a line. Everybody can do that. Mr. Cantor, I didn't understand. Yes, you do. Draw the line. Come on, let's go. All right. And then if it's combustion, I remember CHO. CHO. All right, so here we go. 4 carbons on the left, 1 on the right. Least common multiple is 4, so we're going to factor of 4. Easy peasy, no problem. Over here, we have 10 hydrogens. Over here, we have 2. Least common multiple is going to be 10. We have factor of 5. 5. This is the tricky part, is the oxygens. Oxygens are tricky. So anytime I have an even number carbon, when I get to the oxygens, slow. Over here, I have 2 oxygens. That's easy. Some people are going to make the mistake and say, over here, we have 5 oxygens. Or some people say, over here, we have 8 oxygens. I have to remember that in the combustion reaction on the product side, we have 2 sources of oxygen. So I have to add this source with this source and see where all the oxygen is. Okay, so 4 and 2, that's a total of 8 right here. 5, and this would be a 1, so this is a total of 5. So my total on the right side is going to be 13. All right, and so I already knew that we were going to get an odd number here. If we have even number here, odd number here. So what we need to do is I use a fraction. I just take whatever this number is and put it over this number, and no problem. Okay, so for the last part, um, we have 2 oxygens on the left side and 13 on the right side. So we're gonna have to use a little trick. What I'm gonna do is I'm just gonna place this number over this one. And so that's gonna help us find the least common multiple of 13 and 2. And then it'll also tell us the factor that we need to multiply by. So we have 2 over here, 13 oxygens on this side. Least common multiple of 13 and 2 is 13. And so we have 13 on this side. To get 13 on this side, I just need to multiply by 13 over 2. So that'll be my factor here, 13 over 2. All right, so make sure you use that little trick there. Anytime we have even number, we're gonna have an odd number on the right. So to do that, we're gonna have to use a fraction to get it balanced out. Then the last step is we need to get rid of this. So we don't want to keep that fraction in there. We want all of these coefficients to be whole numbers. So just like in a math problem, we can multiply everything by a factor of 2. We do the same thing here. We're just going to use some math. So this would be multiplied by 2. So over here, now we're going to get a 2 here. 13 over 2 multiplied by 2 is going to just be 13. And then 4 times 2 is 8. And then 5 times 2 is 10. Then, of course, we just want to make sure that everything is balanced. 8, 8, 20, 20. And then now we have 26. Here we have 16 plus these 10 is 26. So if we have a combustion reaction, even carbon, should be pretty easy, no problem. If we have odd carbon, easy. If we have an even carbon, that means we're gonna have to take a little time. It's gonna take a little effort, not much. Don't turn it up to 13, just maybe 6.5. Not a lot of brain power. All right, we'll see you at the next one.